Alright, hello, my name is Jacob, and today I'll be talking about binary. First, you might ask, what is binary? Binary is the language that computers use to think, kind of, like how computers think, and it is only between, the only two symbols in binary are 0 and 1. Now, for when you have one symbol, let's say you have just a 0, this is what's called a byte. It's called a bit, excuse me. So one symbol of binary is known as a bit, and when you have 8, so let's say it's you have 8 bits, you have 8, that is known as a byte when you have 8. And now you might be thinking, what do these numbers mean? When they're all set, is it literally just 1 0 1 1 0 0 1 1? It is not actually. So what it is, so let's say you have the first column, second, third, fourth, fifth, sixth, blah, blah, blah. We'll actually go this way to make it left to right. So the first one is 1, and then you just double after every time. So it's 1, and then 2, and then 4, then 8, 16, 32, and then so on. You can go on however long. And now one of the most confusing things about binary is how you add it. It's a little confusing, but it's actually not that hard. So for example, let's say we have just a random 4-bit set of binary, and then we have just 1 0 1 1. So we're adding this. So what you do is 1 plus 1. It's not 2 like many people might think, because there's only 0s and 1s. There's no 2s in binary. So what this does, it's 1 and 1, they cancel out and equals 0. And then you take this extra 1 and you bring it up here. So now this is 1 plus 0 plus 1, which again cancels out. And you bring that 1 up here. And now it's 1 plus 1 plus 1, which equals 1. And then you still have to cancel out, so you bring that up here. And then again, it's 1 plus 1, which cancels out, becomes 0. Bring the 1 right here. 1 plus 1 cancels out to 0. And you bring the 1 up here. And it's this. This is our answer. Now, if we want to go back and convert it to decimal, which is just regular numbers, 1, 2, 3, 4, 5, 6, 7, 8, you can do that as well. Just check your work. And so this right here, we'll just bring the problem a little bit more over here. So this is considered a 1, and then this is a 2, and this is a 4, and then an 8. So we have 1, 1, so it's 1, plus, and then we have 0 2s, and then we have 1 4, so it's plus 4. And then we got 1 8, so it's 8, and that equals 13. And then this right here, it's 1 0 1 1 1. We got the 1 1. We have 1 2. We have 1 4. We have no 8s, and then we have this right here is a 16. So that equals 1 plus 2, that's 3, plus 4, that's 7, plus 16 is 1 2 3 7. That equals 23. And then if you add these up, that will equal 36. And now if we go back here to check our work, the 1 0 0 1 0 0, this is the 1 2 3, no, not 3, 1 2 4 8 16 32. Let's see, we have 0 1s, we have 0 2s, we have 1 4, so that's 4. And then we have 0 8s, 0 16s, and then 1 32. So it's 4 plus 32, 4 plus 32, which equals 36. So that's just a little easy way you can use to check your math. But this way is much simpler because you just carry it up. This way you have to convert it to check. If you do it fine this way, then this is your answer. If you want, you can convert it to decimal and get the exact same answer. And that is how binary works. Thank you.